We will take a look at Brian Henley's big block Chevy Maverick. Please like and share and subscribe to Ben Alameda Racing.
Old burnout, wasn't it? The 72 Maverick. Big block Chevrolet with an air conditioner on top of it. That's a supercharger, by the way.
There's a lot of interest in my intake port spacers that I used on several small block Fords, and I have about 2 or 3 more coming up and doing the same thing, because it kind of figured a lot of people who wanted a little bit more power without switching to a different cylinder head, and usually you have to buy new rocker arms, new push rods, everything's changed, the geometry. Of course, you can't use the same push rods, or rarely could you use the same push rods. So that said, years ago, when Brad Udell talked to me about his big block Chevy, and I said, oh, you know, I'll take a look at it, so forth and so on. So he did bring the engine over to me, and then when I checked it out, I kind of looked at it, I go, boy, you know, and it was, I think it was a Brodix hit. And it was already fairly maxed out. It's one of their main CNC type porting and all that, and it's up there in the flow range. Therefore, I just decided, I go, you know what? And I'm looking at it. I wonder if I put the manifold higher, and that will change the port angle on the cylinder head. Because there's the intake port, here's the manifold. I go, if I kick it up this way and add a spacer, then I can move all the rest of the port up. So that's what we did. I put it up, I measured the distance, and I put a spacer in between the flange and the intake manifold, and then we welded the top of the roof of the port. Okay, here's the valve that comes in this way. We welded this thing in and kicked it up, and the resulting flow numbers out of that, I think he said 475 or 485. He texted me 475 or 485. I lost all my paperwork when I moved here in Vegas. I had all my cam information in this little folder. I got all my head flow numbers, and I couldn't, for the sake of me, can't find all this information. I have cam grinds for everybody, everything. And it's easy to remember when you've done a handful of engines, but when you've done dozens, okay, and it's hard to remember what everybody's combination was. And so, yeah, I think it takes me like 475 or 485 on the flow at 28, which is pretty doggone impressive. You gotta look at it this way. When you have a big block Chevy head with the left and right port conventional layout, when you flow, you know, 400 plus, 450, 470, that is doggone impressive. And the only way we could have achieved those numbers is to really kick up the floor. Now, one thing, when you have a low port cylinder head, when it's really going full bore on your RPM, and then the airspeed is moving along pretty doggone fast, and now you're getting max lift and everything, and the continued cycle and the fast cycling event that's going on per second, that thing is really moving some air. And if you have the short side kind of tall, you know, from a low port, come up and dive down to the valve, this would be an issue. You'll start to have turbulence issue, and the port will actually shut off at high engine speeds. Now, when you have that little bump on the floor, okay, that's exactly what I'll do. Now, when you kick it up when you kick up the port roof this way, now this angle that comes down here is less drastic. And what actually happens there is that the air column that's coming in, be it fuel injection or carbureted, it will have a better time negotiating that turn and into the short side and then inside to the combustion chamber. When you allow these kind of a reduced angle or not quite as a drastic angle change, then you'll see your RPM go up, your horsepower go up, because now you're just not making any more noise, and you're producing power through the rev range. You know, before, when you have this kinked up port floor, you might, you know, peak and shift at, you know, let's say 7,000, 7,200, and it seems like after that it just makes a lot more noise. Well, when you decrease that angle, now you allow a lot more air to come in without having a lot of turbulence on the floor of the port. And what you're actually seeing is that for the same valve lift, but now you don't have this kinked up short side, but you have this straighter shot. What you're going to see is a rise in RPM. It'll keep pulling to another level. And later on I'll tell you how much we gained RPM wise and horsepower, how much we went up on our peak numbers on the dyno. Well, since I mentioned dyno, okay, let me just go back. Sometimes the dyno will, well, how should I say this? Will give you something. The numbers look good on the dyno. That's what it gave you. You go to racetrack, it's actually slower. I've seen that happen. When we tested, the biggest carburetor showed the most power on the dyno. Well, yeah, that's not hard to do or to believe. Now, when we ended up at the racetrack, this was, I think, Carcraft magazine, somebody. Actually, the quickest one was the smallest carburetor. Oh my God, it's almost the. It was like, you know, the driver looked at me like, "What happened there?" You go, well, that's why we don't race dynos or flow benches. Now, I'm gonna tell a story about a flow bench. Again, man, I feel old when I say years ago. Years ago, I did. Well, how should I say this? I did a plenum, the first plenum. At that time, it wasn't even called an elbow like what people talk about right now. When you see this turbochargers or whatever, they hook up their hoses to the Edelbrock manifold, and they have this elbow. I don't know why they call it elbow. It don't look like an elbow. Yeah. Actually, you know, it's still a plenum. I don't know who coined that thing, but I started that plenum with Bob McClure. When one day he says to me, "Hey Ben, I get something new." I go, "Well, I got something, you know, should be interesting." And so he came down and checked it out. I'll say that to another video later. But anyway, when I first did that, okay, eventually I produced a lot until Edelbrock, TFS, everybody else caught up and started doing their own thing, and they called it an elbow. So whoever coined that name, I don't know. But it was a modified plenum is when I started. But here we go. Eventually I expanded to another different type of engine. It was the 4.6 was there. And I ended up doing another plenum from a factory casting. And I baselined the throttle body with the plenum in it. And then later on, I modified the plenum and I kicked it off to the side. Oh, then I put it back on the floor bench. And now look, not one CFM gain, nothing, nada, nothing. But the amazing part is, I'm listening to the floor bench, it sounded different. Before it's kind of like, you know, it's giving me this weird sound which tells me I got some turbulence going on here. So I kind of figured if I cleaned up because once you do porting so many years, you start looking at something, a port, and you say, okay, this is not good, that's not good. You start adjusting. then you confirm it later on, and usually when you have enough time, like they say on the saddle, you can pretty much predict what it's going to do. So here we go. I put it on, and I was surprised. It didn't do anything. Not one CFM changed. But it got quieter. You know, with the throttle button, I'm listening. I go, okay, it sounds different, but I didn't see anything. Okay, so several days later, I had a guy with an off-road truck. In fact, there's two of them. One was a diesel, and one was an off-road truck. And I gave both of these Plenum elbow. Wow, it looked like an elbow. I don't know. Anyway, so they put it on. I said, let me know how it does. It was actually a coworker of mine at LAPD. And then he says, hey man, my buddy put it on and it responded. His friend had a big tire on this F-150. It's like an off-road truck. And then he goes, man, this thing took off. It had a lot more throttle response, so forth, so on. I'm thinking, okay, I didn't see anything on the flow bench, but he said it picked up. It wasn't his imagination. They said they could feel it. Then another guy with a diesel did the same thing. And he goes, yep, it worked. I go, okay, this is telling me something here. Now come back to another similar truck with the same engine. Actually, I'll say 5.4, them Triton deals. And I did another one for another guy, and he said this. I didn't say anything. Put it on for free, buddy. It's yours. You go, oh, okay, of course, everybody for free. They're willing to try it out. And he came back, and the big smile, you can tell. He wasn't trying to make me happy. He was smiling. He was like, yeah. Anyway, I talked to an SVO engineer then. I said, what do you think happened here? They go, well, maybe the way the plenum was in the manifold, it was turbulent, and the probably there's a lot of stuff going on inside that manifold. Now, when you stabilize that, okay, and spread the flow a little bit more when it discharged to the plenum itself, okay, from the main throttle body, it went down like this, and I did what I had to do. It probably evened and calmed everything down, and you're getting a more even distribution, especially when you stab the gas at a lower RPM. It probably gave a better dividing of the flow into all the other 8 ports. Hence, you have the additional torque without any additional airflow, but it calmed the manifold down. That made sense, okay? Because I should mention his name, the SVO engineer, but when I was at the PRI, he comes up to me and says, hey, how'd you find out about that thing? I go, oh, 4 years ago. I go, 4 years ago? I go, yeah, when I first looked at it, actually it's an LAPD police car, we took the throttle body. If I'd looked at it, I go, oh, that's a bad design. Right out the get-go. I knew it. And I just sat on my ass for the next how many years. And then when I finally put it on, it worked. Okay? And the flow bench showed on the 4.6 plenum. But the amazing part is I had so much heat from just about all the 4.6 guys. Oh, that stuff don't work, and that thing don't work, and they started showing their work. And I looked at it, they took a picture of it. It wasn't right. It was not the way it should be. It is wrong. All they did was clean it up. That's it. Really didn't do any angle change on the plenum. What I did there really made a difference. And like I said, people were on the internet, the keyboard warriors. Oh, that thing don't work. And I came in eventually and I said, I wonder if it's still there when you research 4.6 plenum. I said, look, here it is. If this process is not true, okay? If you think this is some kind of snake oil thing that I've come up with, you will not get anybody to produce what I started You know why? I was up to something. Not only were everybody that bought it that asked for their money back, they're all saying, thank you, it works. But this keyboard warriors who haven't tried it, oh no, because you know what, a lot of 4.6 shops, they were jealous because here I am, a Windsor guy, ended up doing something that they never saw after they've been working with it for the last 4 or 5 years. Anyway, I said, look guys, here's the deal. If this process does not work, then you can say I'm a doggone magician. But in a time when everybody starts producing their own modified Plenum, what's going to happen is it'll justify what I originally started. And guess what? Today, a lot of companies make the elbow or the Plenum. Now it's an industry. Everybody has one. In fact, one has a Plenum that they put a kick in it, a short side kick, which is correct when you're using a flow bench. But really, the Plenum on a 4.6 is already deep before it disperses to all the 8 cylinders all the way around. The Plenum sits on top. They put a kick because they're using the flow bench to evaluate and make their own Plenum, or they call it elbow. It doesn't make any sense because once you bolt it on the intake manifold, it's got a deep, like a 3 or 4 inches deep Plenum there. That's your short side. When you bolt on, then it has its own short side already. But since they were on the flow bench, they go, oh, we'll add a short side here and it should pick up flow. I probably did on the flow bench. Mine didn't show anything because I didn't look for that. I didn't see no, it wasn't real necessary. So here you go. All they did was really lengthen the port floor. Unneeded. There's no need to have done that. Okay, he just made the intake track longer than what it should be when you add a bump on the floor. Boy, but those were a story. Okay, so like I said, flow bench, but now coming back to our big block Chevy, it's not going to be like the Plenum experience. Here we are with a port, and I don't think anybody would disagree with me. If you raise the port and paying attention to the short side and really decrease that angle where the port floor dives into the seat or to the valve, and you know how to shape that correctly, all right, then I don't think anybody would disagree with me that raising the port doesn't make an additional flow. They do. All right, so that's where we started with that, and here you go. Let's start showing what I did. Here you can see the standard height was there before, okay, and what we did was, remember, we welded this and machined it off, and on the initial, when I was doing a lot of flow bench testing, I screwed up when I lowered it right here, okay, and on the other head, and I had to build it up with epoxy. Here's more like a touch-up, and then I started rounding off the corners eventually. All right, could you do this with a solid epoxy? Sure, you could do it, but you know, we elected to weld, and then just to form it finally to the short side, we use epoxy. It's a lot simpler because remember, when you're welding, it's not smooth and it's not, you know, well, it's not flat really. It's all over the place. That's just how it is when you do welding. So epoxy was the final treatment on the surface to get the proper shape going to the short side of the port. Look at how high that is right there. How much it went up. That's significant. Before I forget, this is the factory bolt hole. Okay? And this one on the bottom is what we made to match up with the spacer on the manifold. Okay, so when you line up this bottom hole, it'll sit flush with the port lined up. But that's how much you can see the bolt holes we had to re-drill. Same thing on the manifold. So gasket need to be redone and bring it down lower because the port went higher, and then the same thing with the manifold bolts. There it is, installed on the block, dummy it up, and we're trying to do some more changes there. You can see I'm gonna cut right there, I'm gonna cut right there as well. Okay, that's where the manifold sat, and we had to we don't want anything sticking out. It don't look good aesthetically speaking, so we got to make it as neat as possible. Here's the manifold. Look how high it is. Originally the port is right about here, okay, a lot lower, and of course that changes the way the flow comes into the cylinder head. It likes to run in a straight line. The higher the port angle is, the better off it's going to have a straighter shot to the back of the valve and get more flow out of the whole diameter, or the whole valve diameter, and get maximum flow as much as possible. So that is really very important. And here you see the end plates that we added. Now this plate here isn't as thick as what I've ran on the Fords, because at that time we did a lot of welding on the intake, which we did not do with the Fords. So if we were able to make it up with the plate, because we moved the intake port very high on the cylinder head, and a lot of that was accomplished with welding, which we didn't do with the Fords as much. And I used some epoxy, especially on the AFR. And here we did quite a bit on the roof, and I will detail a lot of those changes. Here's the spacer on the manifold, and we still had to do, you already see some epoxy there. Okay, and I start to continue to cut right about here, right about there, and correct any other irregularities, and round off the edges. And there we get what we're looking for as far as port surface and port volume and everything else. Okay, going to the manifold, from the manifold to the cylinder head. Here you're looking at all the welding done on the intake. That's the push rod hole. That stud, we really had to weld and build it up, because there's not much holding on to the roof of the intake port. That is most obvious. And same thing there, anchoring this Zelle rocker stands. And the danger part here is the roof was so high that we were thin on the edge of the valve spring pocket that it could bust through. And imagine how you end up with the valve spring inside the intake port if it wasn't done correctly. So there we are. All this is done beautiful. Here is the top part of the cylinder head. You notice right there, we built a lot of that welding to raise the port up. Okay, so that was done big time, and up to here, look at that. All right, and over here as well, all the shoring up was done to try to pick up as much flow as possible. That is very important. And all the way here, look at all that. Well, one thing as well, when you raise the port real high, the threads here to hold down the rocker stands, they won't have much meat, okay, and they will fail because they'll pull out, like what happened with us with the small block Ford. We didn't know it was going to be that quickly to pull out, but it is what it is. when you got lots of RPM, a lot of valve springs, and basically the casting is not that thick around this area, but when we moved the port up, that even made it much worse. Now it's only like more than a handful of threads left. That's not enough, so we had to build it up and move everything up. We had issues on the last Ford on the end cylinders not having any kind of support, and the threads lifted up, and the gesso or T&D lifted right here. It couldn't hold it down and pulled up, and you're looking at the end cylinders when it did that. Not the exhaust side, the side of the cylinder head with the intake valve, because there's no other kind of support. Therefore, what we ended up with, Brad, is we have a long steel, okay, good quality steel, not soft. I think this was a stainless or tempered steel, and then we drilled a hole there accurately to anchor this end. There's a step here on the bottom of the gesso stand. Basically stayed on there. Okay, so as soon as that was done, we have no issue. Look at all the shoring that had to do with the cylinder head, because I raised it up there pretty good, and we need a lot of support there. If you're not careful, you can bust through the intake port on the bottom of the valve spring pocket. That's not hard to do when you're really aggressive with this kind of modification. As far as I remember, I think it was Mark Winchester that did all this welding for us. Good buddy of mine up there by the Reno area of California. So close to the Nevada, California border, about an hour away north of that. Now you can see what we had to build up. You can see all the way here. All right. And right around the valve spring pocket, because on the intake port, I'm really, really high already. Okay. And there's not much meat left underneath here. So when we put some threads in there, stainless steel inserts with the correct 7/16 threads, then we're able to torque it with confidence that's not going to pull out. And on the roof part of the port, it gets really close, this one here on the edge, to the top of the port roof, and you can have issues with busting through. And if you don't have a lot of support right here, guess what? You're gonna, go max lift and the valve springs bust through the intake port. That's not gonna be very pretty. And we try to avoid that as much as possible. Here's our big block at the dyno, and you can see the spacer there on the intake that kicked this manifold up. And then we made end seals there out of the same thing to seal the valley tray or the valley pan away from the manifold and keep it from leaking. If you notice how far that is, this end cylinders are standing straight up, and intake carburetor comes in there, the air fuel comes in this way. It couldn't quite take it to the ends, and straight up here on both ends, unlike the ones I showed you earlier. But this really wreaked havoc, and we had distribution problems on this engine. The end cylinders went super lean, and the center cylinders went super rich. As you can tell, we kept adding those, but it really didn't help any. And we tried it sideways, or north-south, east-west location. Nah, it didn't matter. Of course it wouldn't, because it's a square flange dominator. With the raised port or raised plated intake port, and could have done better, but we got the timing retarded big time between running this, keep it from burning up the end cylinders, as you can see how bad this is, and being overly rich in the center cylinders. We couldn't find a happy compromise. In spite of that, with the timing retarded as before on the previous pull before the modification, this one made 35 more horsepower with timing back down, and worse than ever, distribution problem between the front corner cylinders or rear corner cylinders and the center ones. All in all, we consider it a success. And then again, right now it's gone 835 using the same top with 2 dominators. Big difference. Pretty much makes about 1200, 1250 or something like that. Somewhere in that range. Not bad. And it's not a valve spring either, really. It's pretty decent cam, and not overly big, not small either. Here are the dyno numbers for this engine, and it showed a peak horsepower of 1064 at 7700 RPM. And as far as I know, we don't have the last pull at Mountain View. Maybe they have a copy of this dyno readout, but we made about 35 horsepower more, and with the front and center cylinders having a wide difference in air and fuel ratio, we were afraid we were gonna flood the center and cook the ends. So we decided not to push it. Okay, but this 8,000 RPM still made 1,059, but at 7,700 it made 1,064. And torque is 786, 794 at 6,700, 800, 802, 805, 808, 809. That's peak at 6,000. And what we ended up getting, if we can probably get a copy from Mountain View, at 8,200 was the horsepower peak of 35 horsepower more, something like I think the 1,080 was that, or 1,085, but it was 35 horsepower more as far as I can remember, and Brad. But instead of 7,700 as it's shown here, eventually I think it was 7,800 according to Brad. But here it's 1,061, about 3 horsepower. But the peak, the new peak, was 8,200. So it even went up on the RPM scale. And we were able to rev higher. But it was danger lean on the end cylinder and super rich on the center. So we decided that it's time to stop before we do damage on the engine. But it was still very impressive. This dyno test was done several years ago, and like I said on my other Ford-based video, I did my first plate cylinder head with this big block Chevy from Brad Udell's race car. And here it is. We usually want to run on a good, repeatable, and accurate dyno. This one here is at Mountain View, and we find it right there on par as far as accuracy is concerned, just like QMP with my Consolo running the controls there. Same thing. When you get your actual torque numbers and horsepower numbers and you have your converter made, guess what? It matches up, okay? Because if your power is kind of too high, as you think, and then he sets up a converter, well, your stall speed's not going to be the same or anywhere close to that. Or you hope it gets close. But if the numbers are off, your converter is going to be off. Like they said, junk in, junk out.